So the goal of this worksheet using equations is just to review how to solve a problem and then round off the answer so it has correct sig, figs, or decimal places, depending on the type of calculation, and also a review of how to show your work. So the goal is to get practice writing things down. Write down as much as you can. As I've mentioned, even though for your Connect assignment or for a Quizlet, you're just answering by entering a number into a box. But the thing you really want to do is work out the problem, particularly these types of problems that are word problems, that involve equations. You want to write it down and work out the problem on paper, on scratch paper, before you actually arrive at that answer that you're just going to enter into the box. So you have a problem that's a word problem like this. A metal object is dropped into a graduated cylinder, initially containing 5.3 milliliters of water. So anytime you have any number value, that's considered important data. That's a number value with the units. So this 5.3 and milliliter, that's important data, so I'm going to underline it. Causing the water level to rise to 8.7 milliliters. Again, number value with a unit. That tips you off saying, I'm going to use this. And then what is the volume of the object? So this is the thing you're trying to solve for, is the volume. But let's identify what you have here. Are the number values with units are called known information. So you want to write that down. You want to list that out. So copy down the exact number value, 5.3 with the unit. So that's the given data with the unit. And then you want to write the symbol that it represents. So that's going to be some variable, like M is for mass, or uppercase V is for volume, which this is. This is a volume, okay? That's the symbol that represents volume. And that's uppercase V. And how do I know that that's volume? Because liters are the SI units for volume. So you have liters for volume, you have G for mass. Okay, so volume is in liters. M is mass, and that's in grams. And then this was going back to here. This is volume, but you have mass, you have volume, you have time, which can be in seconds or minutes. And you have length, which can be in meters. Let's add that actually. Those are the most common. So that's meters or M. So this is a volume because it has liters with the metric prefix milliliters. That's still going to be volume. Okay. So this is not just the volume, but it's the initial volume, because it was the initially containing 5.3 milliliters. Then you have another number, 8.7 milliliters, so let's write that down, 8.7 milliliters. When you have a number value with the units, you want to write it down exactly, number with the units, and then the symbol it represents. This again is still liters, so that's a volume, but this time it's a final volume. Okay, so what happened, going back to reading this, is a metal object was dropped into that graduated cylinder, caused the water level to rise. So that happened, that's a result of dropping the metal object into the water. So this is then solving for an unknown. What you're trying to solve for is the volume of the object. So this is, again, we want to write the symbol that it represents. This is the symbol V. But this is different from the initial volume or the final volume. This is the volume of the object, so V sub object. Then the goal of writing all those symbols, this V initial, this V final, and the V object, is so that you can find an equation that has all of those symbols in it. Okay, this often, what I've just circled in green, is what people skip. They just go straight to a calculator, or they think you don't need to write those symbols, and you don't actually need to, but it helps you a lot when you're looking for an equation, okay, if you've written those out. So I'm going to go down here and look for an equation that has all of those, the knowns plus the unknown, and I see that this is a good equation that I can use because it has this equation delta V. This is the change or difference, is what this delta or triangle symbolizes. Delta V, change or difference in volume, equals V final minus V initial. So what I did was I just copied this equation and I just moved it up there. Okay, so now I want to use this equation, but before I use this equation to solve for my unknown, I need to make sure that this equation has the unknown alone on one side of the equal sign. It's isolated. I call this isolate the unknown. So that means it's by itself on one side of the equal sign, the thing I'm trying to solve for. So I'm trying to solve for the volume of the object. That was the unknown. And that is, this case, this difference in volume. So this is by itself on one side of the equal sign. It's already isolated. So that means I can just use this equation, V final minus V initial. And how I can use this is by plugging in those values. The value for V final, I want to plug in the number value, but also the units. So not just 8.7, but with the units milliliters. And then I want to plug in the number value for V initial, which is the number value 5.3 plus the units milliliters. So now that you have this is subtraction, milliliters minus milliliters, the units will still be milliliters. You can go to the calculator for this 8.7 minus 5.3. That's going to be 3.4. And for this number value from the calculator, anytime you've gone to the calculator, you need to round by sig figs or decimal places. In this case, this is subtraction. So for subtraction, you're looking at decimal places, and that's the decimal places or DP in the original number values. So this number value 8.7, actually let me go up here and draw it in purple. The original number values are usually way up at the top, so let's go and look at that. So this 5.3 has one decimal place. There's the decimal and one place after it, represented by that 3. And then this 8.7 also has one decimal place. So that decimal and then the place after it, that represented by the 0.7. So the answer needs one decimal place. It has to have the lowest value, so they're both 1. But your answer can never be more precise than the original values. So this is one decimal place already, 3.4. So that would be our plug in our known values. We canceled units and we solved. Check that the units are correct and the answer makes sense.